Hi students. More application problems about volume. So this is the summary. You must watch the video before on my YouTube channel, then you can go to more explanation. So if you have a horizontal rotation and we want to rotate this boundary across the x-axis, you can see one of the axis of rotation is a boundary, so we apply the disk method. In this case, this is horizontal, so it must be dx. So y equal. So here, for this reason, the volume will be from A till B, integral of pi r square. Because the radius here is the function f of x. Always from any point on the x-axis to the function, the elevation will be here. If you have x here, its elevation will be y. I mean by f of x. Here, if you want to rotate, you have this is the y-axis, this is the x-axis. You want to rotate the region bounded between f of x and and y equal, for example, here m or -1, whatever m. Suppose this is y equal to m here, and you want to rotate it across y equal to m from A till B. So since this is y equal to m, so as you can see, and since the axis of rotation is a boundary, you can see here it's a boundary. So we apply the disk method. So we need to find the radius. So the radius is from the axis of rotation towards the boundary. So this r is what, guys? This r is in fact from here till here you have m, and from here till here you have the function, because from the x-axis of the function is f. So r is nothing else than m from this side till that side plus f of x. So here the volume will be from A till B, f of x integral plus m all square. If you have it that sort, you have here the parabola, for example. Here you want to rotate it across the region bounded between the parabola and y equal to m. This is m. So you want to rotate across y equal to m. So also the axis of rotation is a boundary, so we do the disk method. So this is the radius from the axis of rotation towards the other part, the other boundary. Always, guys, I want you to know, when you want to use the disk method, you have the axis of rotation and you have another boundary and the area in between. So always the radius start from the axis of rotation towards the other boundary of the area. So this is the radius. So here this is the radius. So if you want to find the radius, we all know that from the x-axis towards the function, this is f of x. So here it's f of x, and here from here till here it's m. So what will be the radius? It will be the difference, m minus f of x. So it will be pi r square. You do it. Here you have vertical rotation. As you can see, you're rotating across a vertical line. So here, if you want to rotate, so here in this case you must have x equal f of y. Since the boundary is the y-axis, so it's a disk, but it is a vertical. So this is the radius. From here till here, it's x, which is f of y. So similarly, we do it pi r square. And if you want to rotate it across this y equal to m here, you all know from this point here, from the y-axis, we said before, from the x-axis to the function, it's y, f, it means y and f is the same. Here it's not y, it's f of y, because here we have x equal f of y, because the rotation is vertical. So that's why from here till here, from the y-axis, so this is f of y, and from here till here you have m. So what will be the radius in that case? This is the radius from the axis of rotation, which is the boundary, till the other part. So it is nothing else than the f of y plus m. So we do it, we replace it. And if you want to rotate this picture, you can see that this is the radius. So I need to find the radius here. To find the radius, I want to rotate it across x equal to m. I know that, for example, here, if you have this curve, so from here till here, it's f of the function, okay? and from here till here it's m. So the radius is nothing else than f of y minus m and u squared. So these are the only six possibilities. You don't have other than these. So let us start by problem. We have 13 problems to solve. Find the volume of the area between y between 1 and 4. So what do? We want to graph it first. We have x from 1 till 4. So if x is 1, radical 1 plus 1 is 2. If x is 4, radical 4 is 2 plus 1. Take the another point. You can take the 2 or 3. Radical 2 plus 3. Radical 2 is 1.4, so 2.4 approximately. So if you graph it, if x is 1, y is 2. You can see it here at this point. Another point, if x is 2, it's 2.4. Another point, if x is 4, it's here. So it's a curve, it's not a line. So this is the part of the curve, the square root x. You want it between x is 1, this is x is 1, x is 4, and the x-axis, and you want to rotate it across the x-axis. So the x-axis is a boundary, so from here till here is nothing else than the radius. So the radius is the function by itself. So it will be volume from 1 till 4, because I have it from 1 till 4. The radius is square, which is radical x plus 1 all square. So a square plus 2ab plus b square. You solve this integral x square over 2. Here x power half, so you add plus 1 over 3 over 2, or times 2 over 3 plus x from 1 till 4. It's a simple calculation of integral. Here find the volume of the area generated by the same y equal root x plus 1. We graph it already from 1 till 4, and y equal minus 1 around y equal minus 1. Y equal minus 1 is here. Okay, so you want to rotate it. So since this is the area between 4, y equal minus 1, and the curve that we graphed before, so this is the radius. So as you can see here, this radius is from this point till the boundary. This is f of x, and you have down 1, so the radius will be f of x plus 1. F of x plus 1, you have radical x plus 2, so you square it, you expand, you do the integral, and you get the answer. Here find the area of between y equal x squared. So here you need to take particular points between 0 and 2. We're going to take 0, the middle one, 1 and 2. If you put 0, you're going to get 2. If you put 1 here, it will be 1. If you put 2, 4 plus 2, 6, 6 minus 4 is 2. So 0, 2, as you can see, this is the first point. 1 is 1, this is a point, it's a parabola. 2 is 2, so we graph it. I wanted between the parabola from 0, x is 0, x is 2, and y equal to 2. So this is the area between the curve, and so this is the area. I want to rotate it across y equal to 2. Since y equal to 2 is a boundary, so we must do it using the disk method pi r square. So I need to find the radius. So this is the radius from here till here. So you want to do it like this. This is the radius. So if you want to find from here till here, I know from here till here is the function, always from the x-axis, and from here till here it's 2. So the radius will be 2 minus the function. I will get this one. So 2 minus x squared plus 2x minus 2, 2 and 2 cancel out. So it will be, this is square, pi r square. So I expand and I find the volume. Now I want the volume of the area bounded between. Now I have x equal f of y, so it is a vertical from 0 till 2. So I put y 0, 1, and 2. So if you put 0, if y is 0 here, you're going to get 5. If it is 1, you're going to get 0. If it's 2, you're going to get 5. So you have 0 is 5. You can see it. If x is 5, y is 0. This is the first point. If y is 1, or if x is 0, you have 1. This is another point. And if x is 2, you have 5. So I have these 4 points. So these 3 points, so this is the, it's a parabola, but it is because it's a square, but this parabola is or not vertical, horizontal. Why? Because x equal y squared. So that's why I want to find this area bounded between 0 and 2. I want to rotate it across the y-axis and the y-axis across the y-axis. So I have this region. So it's a disk method. Why? Because the boundary is an axis of rotation. So the radius from here till here is nothing else than f of y. F of y is what? 5 into y minus 1 square, pi r square. I square it again. So here let u equal y minus 1. I do a chain rule. Du equal dy. So 25 u 5 over 5, and you solve the integral. More example. Here also I have 5y square. So you can do xy. You have 0 and 1. You can take one of them which is the middle. 0, half, and 1. So if you do 0, you have 0. If you put 1, is 5. If you put, so it will be 1.25 here. So what do we have? 0, 0. This is the first point. You have 1.25. This is 1.25. You have 1. If you have 1, if x is 5, sorry, y is 1. So I have these 3 points. So I want from here to this, the curve. I want it from x equal from 0 till 1, y0. This is y0. Y equal 1. This part here, this part, and x equal minus 1. Around x equal minus 1. So this method. So the radius, it must be from here till the other extremity. So I know from here till here it's f of y. I know from here till here it's 1. So the radius will be f of y minus 1. F of y plus 1. Sorry, the radius I want it from here. I know from here till here it's, as we said, f of y, and here from here till here it's 1. So plus 1. So I square it. You can square it a plus b all square, a squared plus 2ab plus b squared, then solve the integral, or you can use the chain rule. Both will be the same. So here, number 6, find the volume bounded between x equal to y minus. So this is a line. You can know if y is 1, you have x is 0. If y is 1, x is 0. So this is the point 0, 1. And if y is 2, x is 2. So 2 and 2, you can see it here. It's a line bounded between this line, y equal to 1. This is y equal to 1. Y equal to 2, and x equal to 2. So this will be the triangle, the right triangle. I want to rotate it across x equal to 2. Also, this is disk method because the axis of rotation is a boundary. So this is the radius. I know that from here till here is the function, and I know that from here till here it's 2. So the radius will be 2 minus the function. So if you do 2 then minus the function here, 2 minus 2y plus 2, you're going to get minus 2y. You do pi r square, you get the answer. More problem. Volume by rotating the area given in the figure around the x-axis. Now the figure is given. You want to rotate it across the x. This is a vertical rotation, so it's y equal disk method. The radius is from here till here, which is the function. So from 0 till pi over 2 sine x cosine x all square. We know that here you must remember sine 2x is 2 sine 2x cosine. We know that sine 2x is 2 sine x cosine x. So here I have sine x cosine x. It will be sine 2x over 4. So remember, this is a formula. I gave you a formula, sine u squared. So let u equal to x, so du equal to dx. So it's in the form of du. You're going to get this one, and sine square u, it's already a formula that you know. You can find the volume. More, find the volume by rotating. This is a parabola. Y equal x square. You have y equal to 0 in the x-axis. This is y equal to 0. X equal to 2 and the parabola. So you take here one time y is 0, so x is 0. If you put by 2, you're going to get a 4. So this is the parabola. you want to across the x-axis also it's a disk, so the radius is nothing else than the function, so pi r square. So you do it, it's very simple. Here you want to rotate y equal root x from 0 till pi over 2. Cosine 0 is 1, so 0 is 1. Cosine pi over 2 is 0. You can take, for example, pi over 4, which is radical 2 over 2, and you do radical of it. So you're going to get a value. So this is the shape between x equal to 0, x equal pi over till pi over 2, and you have y and you have y equal to 0 we said, x equal to 0, and the curve around the x-axis. So this is a simple disk method. This is the radius. So you square this one, it will be cosine x, and integral of cosine is sine x. So as you can see now, it's very simple. I have y equal to sine x between 0 and pi over 2. Sine 0 is 0, sine 90 is 1. You can pick sine pi over 4, which is radical 2 over 2 times 2, it will be 1.4. So this is the curve. And on the left by the y-axis, this is the y-axis. And you have, and the line y equal to 2. So this is the area, y equal to 2, this one and that one. You want to rotate it across the y. Because it's across the y axis here, about the line y equal to 2, sorry, y equal to 2, so it's horizontal. So I want to find the radius. I know from here till here you have 2 sine x, and from here till here it is 2. So the radius will be from here till here is the radius. You all know it must be like this. So it will be 2 minus 2 sine x, 2 minus, or 2 into 1 minus sine x. So pi r square, you square it. So it's of the form a minus b square. Sine square x is a formula. No need to do that one. I gave it directly as a formula. You can replace it directly. And the integral of 2 sine x minus 2 sine x is 2 cosine x. You have secant x from y equal to 0 is nothing else than the x axis from minus pi over 4. Now cosine pi over 4 is radical 2 over 2, or minus radical 2 over 2. The inverse would be 2 over minus radical 2. You can use your calculator. You get here a point. Take the middle to know how the curve looks like. If you put 0, we know secant 0 is 1. So this is 1. So this is the... No need to have an accurate image. We have it from minus pi over 4 till pi over 4. And you have the x-axis, which is y equal to 0. You want to rotate it across the x-axis. So this is what a disk method. So this is the radius, which is nothing else than the function. So secant square x is a formula. Integral of secant square is tangent x. You solve it. 12. The region in the first quadrant bounded above by the line y equal root 2. This is y equal root 2. Below by the curve, this one. So we need to take particular point. And on the left by the y-axis, which is this one. And y equal radical 2. We said about the line y equal to radical 2. So you need to take particular points. So you can pick first of all 0. Secant 0 is 1. Tangent 0 is 0. Here, for example, we took more points. If we take pi over 4, in this kind, in any quiz, I will give you from where till where. So here you need to take particular points, and you see that if you put pi over 4 here, secant pi over 4 is 2 over radical 2. Tangent pi over 4 is 1. So this will give me, if you rationalize, radical 2. However, I will tell you from 0 till pi over 4 to make things simpler. Okay, so I will give you this one. I add this one. So it will be now easy. So this is the curve that I have. You want to rotate it across y equal radical 2. So this is the radius. So I know that from here till here is the function, and from here till here it's radical 2. So it will be radical 2 minus this one. I need to square it. So a square minus 2ab plus b squared. And a secant tangent is a formula of the integral, which is secant. Here I know that tangent square is sine square over cosine square, right? And secant square is 1 over or here you must do a chain rule. You're going to say let u, we did similar to this problem, let u equal tangent, derivative of tangent is secant square. You can do it a chain rule. You can check it by yourself and review a little the integral. 13, I think that 13, ah, I have 13 till 15 still. So now if you want to do 13, bounded above by line y equal 2, this is y equal 2, below by the curve I gave you from where to where. Sine 0 is 0, sine pi over 2 is 1, times 2 is 2, and on the left by the y-axis, and you have the curve. You want to rotate it across y equal about the line y equal to 2. It's also a disk, so I want from here till here. So directly it's the function. From here till here is the function, and here is 2. So it will be 2 minus this one. We solved one similar. So you can solve it or the same, or it's a repetition by mistake. I don't know. Anyway, the region enclosed, you have x equal, so it must be of that 4 horizontal one. You have x is y from -1 till 1. So this is y equal -1, this is y equal to 1. So if you replace from -1 till 1, you have radical 5. So if you have radical 5, you have this point. You can pick for y a point between -1 and 1. Remember x, y. I gave you y. You can pick -1, 1. You can pick 0, minus half, half. If you pick 0, you have 0. So since it's a parabola, it must pass by these 3 points. You want to rotate it across the y-axis. So it's a disk method. So this is the radius, which is nothing else than this function. You must square it. So you solve it. The last one, you have x equal from y equal to 0, 3. So y 0, you can pick 1, you can pick 2, you can pick 3, whatever. If you put 0 for y here, you have 2 over 1, which is 2. If you pick 1, 2 over 2 is 1. If you pick 3, 2 over 4 is half. So if x is 2, y is 0. If x is 1, you have 1. And if x is half, and sorry, if x is half, this is half, y is a 3. So this is the part. I wanted between x equal to 0, x equal to 0, the y-axis, sorry, the y-axis. From this part you have this one. Between y equal to 0 and y equal to 3, this is y equal to 0. So you have this form. You want to rotate it about the y-axis. So this is the radius here, which is the function itself. So if you square it, you can put 4 outside. You do a chain rule, let u equal y plus 1, du is dy, so you're going to get integral u minus 2 du, which is u minus 1 over minus 1, so it will be minus 1 over u, and you solve. So as you can see, this is not difficult. Be well prepared, and see you on Monday.